Hello, everyone, and welcome. I'll just give a few minutes for everybody to join us. Thanks for being with us today. Super. Actually, maybe I will kick off with a bit of an introduction and we'll let the others join slowly. But I just wanted to give a warm welcome to everybody who's joining us for the webinar. My name is Stephanie and I'm the Association Manager of Chapter Zero Brussels. And we're really happy to do this webinar today to really shed some light on how Belgium is going to reach climate neutrality by 2050 and some of the challenges and opportunities along the path. And we're very thankful to support from CLIMACT to organize this webinar together with them. So yes, myself, I will be the moderator today, and we're really happy to have Julien Pestiaux, who's a partner from CLIMACT and also a board member himself, come and speak to us on behalf of CLIMACT, and also very happy to have Pierre-Henri, who's head of sustainability at ILIA, and also a board member at Guberna, to come and share ILIA's perspective as well. So thank you to you both for being with us today. I'm just going to quickly show the agenda of what we will cover. So first, Julien will take us through, what is Belgium's net zero pathway? Actually, how are we going to reach 2050 and answer some of the big questions around that. And Julien will also explain why CLIMACT was involved and how they were involved actually in helping the Belgian government understand that pathway. And then we've also invited Pierre-Henri to come and share ILIA's perspective, both from the company side of how a company is then taking this into account, and also ILIA's in a unique position to also be supporting the transition themselves, so being a key player in Belgium's transition as well. We'll also have some time at the end for Q&A. So I would ask you to, throughout the presentation at any time, use the Q&A function on the webinar, post in your questions, and at the end, we'll try to get to as many of them as possible. So please feel free to pop in your questions there, and we'll be moderating that throughout. So without further ado, I'm going to hand over to Julien for the first part. And thank you once again for being with us all today.
Thank you, Stephanie. Thank you very much. It's a pleasure to be able to share some of the insights we've developed over time, and also to do that with Pierre-Henri from ILIA. I'm just going to share my screen, which I hope you can see now. And start by shortly introducing myself and the team. We're CLIMACT, for the ones who don't know us. We do consulting for around energy and climate change, and we do what we call prospective studies, which is more medium to long-term studies, particularly for administrations in Europe, but also beyond Europe. We also do strategic consulting for companies, and we offer regulatory advice on that. And our mission is really to help empower our clients to act on climate change. And so you see here the range of sectors that we cover, more on the corporate sides, and the type of clients we support also on the public side, from administrations to NGOs and foundations. So I don't have a lot of time to run through the key messages that I have for you, but I do want to first spend a little bit of time on the fact that the ambition is rising, and that's across the world, but that the policies behind them actually don't add up to get there. And then I'll shortly highlight how our models are trying to support the implementation, and then get to the key messages that form the core of the presentation around Belgium achieving net zero by 2050. And the last point is to make the connection on some of the work that we do for ILIA on assessing the short-term impacts on electricity demand. So clearly, and you're probably aware of this, but there is a trend across socioeconomic trends and Earth-related trends of increased speed of the transition, and that covers elements, of course, like population and increasing trends around transportation, energy use, of course, and then the impacts on the Earth around, of course, greenhouse gas emissions, which is what we're about to discuss today, but also related to biodiversity and ocean acidification and so on. So the trend here is very visual. You see that after 1950, there's been a large increase The connection, of course, is here on temperature, on average temperatures, which are today already about 1.1, 1.2 degrees above the pre-industrial range. And so that's leading to very concrete changes already today. And you're aware of last summer, for example, with the droughts in France, the fires in Spain, the hurricanes in the US, the flooding in Pakistan. So with 1.1 and 1.2 degrees, we're already seeing a wide range of extreme climate events. And so the difficulty is that the 1 degree, the average, actually hides large differences, not only between continents and the ocean, but also over time. And so the extremes are getting larger, and the difference also between the future of a 1.5 degree or 2 degree increase, or obviously more, is very stark. Not only in the frequency of events, you see here the frequency of extreme temperatures, which would not only increase by 5, but by 15 in a 2 degree world, but also in the intensity of those events. You see here that it would get 2 to 3 degrees hotter in those extreme events. And so I don't have to tell you that the ambition and the speed of ambition needs to increase. The good news is that the amount of countries that are sharing ambition is increasing, and we're close to 90% of global emissions, which are now covered by net zero targets, and that includes the large emitters like Europe, China, and the US. Unfortunately, the connection between those ambition and actual policies is not enough. There's a massive gap between those ambition and the implementation. And so you see that currently we're still, based on current policies, on a 2 to 3 degree increase by 2100. And the trajectories that lead us to 1.5 are much lower. So there's a need to increase ambition, and here you see the contribution of Europe on global emissions. It may seem relatively low, but not one country will get there on its own. China is 24%; it's the largest emitter, but still, would China stop emitting, it wouldn't solve the issue. We just need to, all of us, reduce emissions across the whole globe. And also, obviously, Europe is trying to show some leadership there with the climate neutrality, which has been agreed and put into law. And so there is concrete ambition in Europe. Obviously, behind that law is now I just wanted to shortly mention that we're talking about net zero. So that's lowering emissions on one side and also removing the potential remaining emissions on the other to get to net zero. And I'll come back to that when I touch on the scenarios for Belgium. So Europe is kind of setting the tone, or trying to set the tone with the Green Deal, and really trying to push across a lot of different dimensions, obviously on the climate ambition itself, but also on improving the circular economy elements, obviously touching on building, on transports, a lot of issues concerning agriculture and food, also trying to look at biodiversity and preserving biodiversity, and trying to do that while leaving no one behind, trying to have a just transition. So this is sufficient to say that the ambition is extremely high. How do they try to do that? They've now put in place the Fit for 55 package, which is a very broad legislative package to try to align those policies with the ambition. And the ambition is increased. You see here how it goes from Europe ambition to Belgium ambition, from the 40% now to 55%. So that's the number that most of us have heard about, the 55% reduction by 2030 compared to 1990. And so that's really what we're trying to get to, and that's split between the industrial sectors and aviation, the ETS sectors that are known today, which have a 62% reduction targets, and the non-ETS sectors, which have about 40% target. And for Belgium, that is leading to a reduction requirements of minus 47%. So that's just to give you very quickly the legislative background of what we're needing to do. But clearly, what we're seeing concretely in Belgium on the ground is that the ambition is too low. You see here the historical evolution. This is indexed to 100% in 1990. You see that the current existing measures are not leading us to reduce. They're actually not only stabilizing, but actually with a slight increase. And the NECP, the National Climate Plan, is roughly stabilizing, leading us to stabilize emission. What we need is a much larger decrease to get to this 55% from the Green Deal. If we don't do that, it's clear that the trajectory between 2030 and 2050 will be much steeper after 2030. There is a new plan that must be coming here in June. The draft should be coming in June for all of the member states. And then next year, the final version should be available. So this is really a time where there is a need for everyone to try to encourage the member states for higher ambition. So how has Belgium started to look at this? They've analyzed a series of scenarios, and we've helped them with the model that we've developed over the years. And then they've crystallized the scenarios with three of them that you see here. And I will come back to each of those scenarios afterwards in the results. It's a more central scenario, which is called the core scenario, and that has a balance between technological and behavioral or societal levers. And it's called 95 because the 5%, the last 5% is done through removals. So this is where I go back to this concept of reducing and then offsetting the final 5% with removals. And next to that, there's a behavioral or societal scenario that looks at major changes in terms of how society functions, reducing the demand for products and transport, shifting transport from cars to public transport, shared mobility, etc. And then there's a technological scenario that looks at more the major technological deployments that we could imagine. Not only energy efficiency, but obviously electrification that will be a major element of the transition, and alternative fuels. So I'll come back to those when I talk about the results. Here you see that this was also obviously backed up with other reports that the administration has done over the years, and we're basically adding another brick to that wall. So I will try to really go quickly through this section, because the point is not to give you an overload on what our models do, but just to give you a sense that we've been developing those over the past 10 years, and that's been starting, and it's basically looking at all of the different types of geographies, from the global version of the models that we've done in the past to the European versions, working extensively with the European Climate Foundation, to then the national version and the website that we now have that declines the work for all member states, but also beyond to countries like Brazil, India, and China. And then sectoral roadmaps, looking at those for various federations, and also now a city version of the tool to really help implementation at the more concrete level for cities. And so this is the interface of the tool, which is available online. And this is an example of a concrete use of the tool, if you like, for Belgium, looking at the industry. And on the left hand side, you have all of the levers that can be pulled. Of course, if you open up that the menu there, you have hundreds of levers that are available for testing the impact on the transition. And here you see that if we pull all of the ones for the industry from 1 to 4, from the least ambitious to the highest ambitious, well, we get an impact of about 30% on total emissions in Belgium. So that's a very quick look at how the interface works. And this is the geographies covered right now with the tool. I'm not going to go very long through this, but it's just the connections between the various sectors that we have. So going then to the actual content as I mentioned, it's really the objective of testing and looking at a wide range of scenarios to understand what impacts concretely the reductions on the ground. And so the pathways we've developed with the administration, with the federal administrations, are clearly trying to help them understand the levers that they need to pull to reach that famous target of being net zero by 2050. And of course, we do find, well, not of course, but we do find that it's technically feasible, which wasn't a given when we started off. The time is, on the other hand, certainly running out. This was done already 2 years ago, and obviously the implementation between then hasn't been enough. So there is already 2 years lag, if you like, and that needs either to increase then the pace of the following years, or means that we'll be missing that target by 2050. We see that very structural changes are required, and that's not only for the energy system. It's not just about plastering our country with solar panels and adding nuclear power plants. It's really about looking at all of the sectors, our consumption, transports, buildings, diet patterns, and so on. And in the result that you'll see, it shows how both societal and technological levers are having an important impact, and how they each add value to the system. So first element here on energy demand, you see the result in terms of final energy demand compared to 2015 across the key sectors and compared to the reference scenario. And you see how massive that decrease in energy demand is across all of the sectors. This is really at the core of the transition. It's really about being much more efficient and careful about the way we use energy. And this is happening through both activity levels, but also obviously through the technological switches and breakthroughs that will be used over time. And so that means much higher efficiency, switching to electrification, which is also in itself more efficient for transport, for example, but also for heat pumps. And all of these factors together lead to very strong reductions. This is, by the way, also true for, of course, the societal or more behavioral scenario, but also for the technical scenario. So going for a much higher ambition through the technological levers also lead to strong reductions, and that's connected to what I was saying before. It's really all of these technologies that use much less energy because they use electricity more directly. And the one scenario, the one sensitivity we've done here is to look at the highest demands that we can see and still reaching net zero, and still there you see that it's quite a large decrease. It's the industrial sector that here decreases least in that case. So decreasing energy is one thing, but how is then the mix of energy really changing? And here you see the evolution in final energy demand, and how, well, you see that same reduction that we talked about in the previous slide, but you also see how the mix changes and how electricity is taking a much larger share in this new configuration, and how also then some of the liquid and gas e-fuels come to complement this electricity. Fossil fuels they clearly become much smaller in share, from 77% to 7% in final energy. And then they would be partly captured through carbon capture and storage. So energy is one thing. The other very interesting side of the transition is around really our use of materials. Here you see how material demand is being vastly impacted by the various levers that are put in place. And this is grouped in various types of levers. You see here more of the consumption patterns. So by sharing goods and appliances, by reducing waste, by ensuring, for example, that we share cars more efficiently. These are all levers that lead to a first reduction in material demand, because they lead to a lower need of cars, for example. Transport patterns themselves. So if we reduce the demand for transport, production patterns, if we shift certain materials to others, we have here quite a large impact from production patterns. And so altogether, if we add to that other levers that are being done in the sectors themselves, we get to about a 44% reduction in material demand. And that's really across cement, chemicals, glass, etc., across all of the sectors, through all of these, what we could call circular economy levers. And if we compare that to the other two scenarios, the behavioral and the technical, you see that with societal changes, we could go even beyond that. And the technical one reaches about 30% reduction in material demand. Just a short word on the 5%, which I mentioned on land use. It's a whole sector that we could talk about for an hour or more. But it's really this concept of trying to shift diets to healthier diets, and also reducing the amount of meat, not only meat that we eat, but also that we export, because there's a lot of exports today of meat from Belgium, and that can lead to a shift from croplands to alternative land uses like forest and grasslands, and those are better for capturing CO2 from the atmosphere. So very good, you'll say, but what is this going to all cost? So this is a couple of slides on first the expenditures, so the investments that are required for the transition. And here you see how between the reference scenario and the core, there's an increase in certain sectors like buildings and industry, which require much larger investments to become carbon neutral. And this is clearly through all of the renovation of buildings, for example, that we have to do. What's interesting is that the transport sector will really be defined by the type of transition that we do and how we look at mobility in the future. If we look at mobility in a different way, and we manage to increase the amount of public transport, but also encourage autonomous vehicles and share mobility, we'll actually have a lower fleet of cars, and so lower capex overall for society. So assets will be used more efficiently. Normally, cars are being used about 3 to 5% of the time, and the rest of the time they stay idle in parking lots. Here you see how if they're used more efficiently and they're being shared more, the amount of capex for those would reduce. So that's to explain why, in this case, the total cost of the investments is lower. That's not the case in the technical scenarios and in the high demand scenarios. So if there's more focus on technology, then there'll be a higher increase in capex, in capital expenditure. In terms of the fuel cost, this is clearly why we also want to do the transition. You see the evolution of fuel cost here in the reference scenario on the left-hand side. And this is how they would evolve with much higher costs for electricity, which is the green part here in the middle, but the disappearance pretty much of the costs for the fossil fuel parts here on the left-hand side. So this is why the transition can be also macroeconomically attractive. If we reduce the amount of fuel that we have to buy from abroad, all of these fossil fuels, and we focus on building and investing in Europe, in Belgium, we redirect all of those financial flows towards Belgium. And typically, that's part of what Pierre-Henri could be telling us also afterwards, because it's basically expanding our grids, increasing our infrastructure here to be able to capture the shift towards more electricity demand. So there are also other reasons. That's the final slide that I wanted to show here. There are also other reasons to encourage the societal changes, and so more of the behavioral elements. It's really that the impact of technological change is not only felt on emissions, but also on other dimensions, be it the amount of fresh water that we need to use for some of those technologies, the impact on the biodiversity and so on. this is an element that's often left aside, but it's really key in understanding why the transition is required and why it needs to not only look at the technological side. So this was basically the very short presentation that I had the time to make. I'll be happy to take some questions, some focus questions afterwards. But our conclusions are really that achieving climate neutrality is feasible. It does require additional capital expenditures, but it leads to lower fuel costs that really supports the attractiveness of the transition over time. Electrification is key. And it's important to also look at other aspects around resources and land. And the fact, as I was mentioning again, that systemic changes are required both in terms of technologies, but also in terms of societal and cultural changes. And I know I've run out of time, so I'm just going to mention the fact that that we've done quite a bit of work with Elia, and it's been interesting to support them on trying to assess more of the short-term impacts of the transition towards heat pumps, for example, and electric vehicles. And this is done with the model, but also looking at macroeconomic indicators and how these will evolve based on projections from the Federal Planning Bureau in Belgium, looking at how income will evolve, industry added value, and so on, and their impact on key levers and key changes in society, and that leads then to a certain projection for short-term electricity demand across the sectors, and that's been done over the years to try to track how that electricity evolves. That was it, Stephanie. Sorry if I
Thanks, Julien. No, I think it's okay. And actually, before we switch to Pierre-Henri's presentation, I just wanted to ask you one clarification question that came in the chat, which might be, you might want to show the slide again. But yes, there was a question from Anne, just to reiterate again, I think in the core scenario in particular, how much of the mix comes from behavior and technical influence, actually. So I think you showed 3 different models, but in the core one in particular, how much of that is coming from behavior? And Anne is asking also because, this kind of difficulty in actually changing consumer behavior. So I don't know if you want to just say a few words quickly before we move on what kind of is behind this assumption of behavioral change, because it does seem like a challenge indeed. But...
Yeah, I think I have other slides that are capturing that for certain sectors maybe better than the general ones. If I take this slide here, for example. So this is an example, a concrete example for transport. You see here the impact on energy demands based on reducing demands, shifting modes to more public transport and active modes, and the amount of car sharing, so how filled the cars become as well. And then there's the technological shift and the energy efficiency. So in this case, I wouldn't say it's half and half. It's slightly more related to this, but I really want to underline that this here also requires technological changes, because it's a mix between taking the public transport, but also having the opportunity to take that public transport. So it's really about also the trains becoming more and more readily available. Autonomous vehicles being potentially there, that's more for the longer term, more like 2040, 2050. But so this middle element here is very much a mix between a change in how we see mobility, but also the need for technological deployments.
Okay, thanks. So yeah, probably this split will differ based on the specific lever, and the mix in between might be different. This is a great example for the transport to show how it's split. Thanks a lot. So I'm sure we'll have a lot of other questions, but before we get to the Q&A, then we'll hand over to Pierre-Henri. Thanks again, Pierre-Henri, for being with us today. And we invited Pierre-Henri to look at 3 main questions for us. So on one hand, and Julien alluded to that, what is Elia's role in this kind of transition of Belgium overall? But then also, how is Elia as a company dealing with their own decarbonization plan? And in particular, Pierre-Henri, if you could talk a little bit about, what were some of the challenges in setting that strategy for the company, And in particular, I think what we hear from the board side is really this difficulty dealing with the long-term uncertainty. So we're thinking about decarbonization all the way to 2050. It seems very far away. Some of those technologies we don't know yet. You talked about autonomous cars, for example, Julien. So kind of like how do you set a strategy and how do you deal with that as a company, taking into account all this uncertainty that's still out there and thinking about how a board member might be able to deal with that. So those are some of the questions, easy ones that we asked Pierre-Henri to think about with us today. So I'll hand over to you now. Thanks a lot.
Oh, thank you, Stephanie. Thank you, Chapter Zero Climate as well, Julien, for having us. A pleasure to share some thought. So we have 10 minutes to share some thought of these three key questions. Just had a few slides I'm going to share with you, but it's more, I would say, a testimonial than a presentation itself. So slides are there just to support the narrative. So first question maybe, and I know some of you in the room are already familiar with Elia business, some are not. So just to set the scene, so Elia in Belgium, so Elia Transmission Belgium is responsible for the electricity transmission system. So you can see on this slide a picture of the value chain. Basically what we do, we are responsible for transporting electricity from where the electricity is produced on the left-hand side of my chart to where the electricity is consumed, going through the distribution network for the residential sector, and then we have some industrial customers that are directly connected to the Elia grid. Okay, and this is linked, I would say, Stephanie, to your first question. What is the role of Elia in this global decarbonization story? I think we should see Elia as the catalyst, as the enabler. And we summarize, in the bottom of the slide, the 4 main societal tasks that we have to make the energy transition happen. The first one is managing the infrastructure. And that means 2 things. That means reinforcing the current backbone. And so we do have an electricity network today, but as Julien mentioned, we expect a strong increase in electricity consumption, not only in Belgium, but at European level as well. If we focus on Belgium only, Julien shows on slide until 27, what we expect is that between now and 2032, so in less than 10 years from now at Belgian level, the electricity consumption could increase by 50%. Okay, so our societal responsibility is to make sure that the network is ready to welcome this increase of electricity in the global energy mix, because it's an enabler to decarbonize the sector. So that's the current backbone, managing the infrastructure. It also means anticipating new infrastructure. And I'm going to show you afterwards some project that we have in the pipeline at the moment in terms of new bid. But infrastructure is not sufficient, and that leads us to the second pillar, which is balancing the electricity system. So second responsibility of Elia is to make sure that at any time the consumption is equal to the production. And where it used to be already a challenging task, it is becoming even more challenging now with the intermittency of renewable energy in the system. When we have sun, then we have an increase of electricity production, wind, same thing. So there is much more intermittency in the profile of electricity production in Belgium than before, and more globally in Europe as well. At the same time, we do have also other pattern on the consumption side, where indeed people are using electric vehicle much more often than before. So modifying also the consumption pattern. And so the second mission is to make sure that in this future world with electricity will take a much bigger part of the total final energy mix, that we can ensure adequacy and grid stability to keep the light on at any moment. And then finally, I would say the third point here, facilitating the market, I would like to mention here is that so not only we operate the infrastructure, we make sure that the grid is always balanced. There is a third pillar as well, which is how can we design a market mechanism? And so really how the electricity market works to make sure that we are prepared to this significant increase. And there, for example, one of the examples that we are working on at the moment is how can we make sure that we can use as much as possible the flexibility that the residential sector has, okay? And so it's also kind of collaboration with the distribution network operator, the DSO of this world, but flexibility in the residential sector and industrial sector will play a key role in the decarbonization as well. Because if we can play with the flexibility that we have in our consumption point, that can allow Belgium as well to avoid, for example, building a new gas central, because we can rely on capacity which is on the customer side. And then trusteeship, which is the mission we receive from the legislator to ensure this. So briefly, this is what ELIA is doing. And then this is, as I said, all of these 4 missions are really an enabler to make sure that at national and international level, we can reach the objective of the Green Deal that Julien mentioned earlier in the presentation. The Fit for 55, we want to decarbonize Europe. We want to reduce the global emission of Europe by 55% by 2030. Then to do that specifically, then ELIA needs to make sure that the grid is ready to integrate as much as renewable energy as possible. So it's not only that we need to produce more from renewable, but we need to make sure that we have the global infrastructure to welcome this renewable energy into the system. That I mentioned. And then, yeah, offshore, we haven't tackled it yet, but offshore will play a key role as well. So Europe has an ambition to really increase the installed capacity of offshore wind until 60 gigawatts by 2030. And I wanted to give some example of you what does that really means for Belgium as well, and how offshore will play also a key role in the decarbonization of Belgium in the energy mix that Julien presented earlier. Just to mention, ELIA also, ELIA Transmission Belgium is actually part of a larger group, ELIA Group, SANV, so listed in Belgium, but we do have other activities regulated or non-regulated in Germany and other countries. That's an example, for example, of what we are working with for Belgium. So we are, investigating the possibility of building an interconnector between Denmark and Belgium to ensure that the green energy, which is also produced in the Nordics region, can actually flow in real time to Belgium. There is no correlation between the wind forces between these 2 regions of the world, meaning that statistically, when there is a lot of wind in the Nordics, and they have much less wind in Central Western Europe and the other way around. So it's actually a mean also to allow the electricity flowing from one country to another in order to avoid building extra capacity in our countries. This the energy island, you have heard about it a lot over the past few months. This is one of our projects when we are going to build the energy island in the North Sea, facilitating the development of offshore wind in the entire zone. And then, of course, in Belgium, we want to reinforce the onshore backbone to welcome this extra gigawatt of power that will contribute to the decarbonization of Belgium. Your second question, Stephanie, to respect the time, was what do you do also internally for your corporate activities? And that's exactly the difference that we make at ELIA. And the first question is more about our societal mission. So it's really how we can enable the decarbonization of the power sector and the industry as a whole in Belgium and other countries where we are active in. The second question is more as a corporation, as a company, what do we do, just like any other company, no matter what business model we have. And that leads me to this slide. The answer to this question is, find an answer 2 years ago when we asked ourselves this question, what should we do as a corporation to decarbonize our own activities? And it led us to our Act Now program, which is rated as the ESG program of ELIA Group. So we do have this program at group level, so it's the same program for all the legal entities within the group, where we tackle this discrete question. Important to mention as well that we didn't want also to have like an ESG strategy or a sustainability strategy next to or on top of our corporate strategy. There is just one strategy, the corporate strategy of the group, which needs to be sustainable. And so all about our ESG program, Act Now, it's not a strategy in itself, but it's specific component that we have been added in the corporate strategy as a whole to make sure that the corporate strategy is sustainable. Okay, and so to come back to the very precise question, what do we do? Then if you look at the scope 1 and 2, which is when we talk about scope 1, 2 of emission, it's basically our own emission in our control area, including the electricity that we consume. Scope 1, for example, we do have some equipment in our fleets that emit SF6. SF6 is a chemical substance which has a global warming potential called GWP, which is 25,000 more nasty for the environment than CO2, meaning that the impact on the environment is important. And so we decided, and the decision was approved by the top management, to engage in a phase out of this type of equipment 2 years ago, in order to go to equipment that have a much lower GWP. And what we are seeing actually is that we anticipate that 2 years ago, and Europe actually came in a year ago with the F-gas regulation within the Green Deal that Julien presented, saying, by the way, SF6 also need to be prohibited. And so that was a sign for us that our strategy was well thought, because we kind of anticipated the legislation on that in our portfolio. Second action is ELIA, being in the power sector, can also be seen as a kind of real estate company, because we do have a lot of building. So in all the connection lines in the country, we have what we call substation, which are building at the intersection of several lines. And in Belgium, we have, for example, 800 substations. Some substations have several buildings. So in total, we have more than 1,000 buildings in Belgium. And so our own electricity consumption for heating, for example, is quite significant as well. And so we launched a program called Green Substation, where we want to do two things. We want to reduce the electricity consumption by, for example, playing on remote control system for heating system. And we are also going to install solar PV on site to produce our own electricity for our own needs in a substation, so not being injected to the grid. So that's a second example. And then maybe a last one is also we have integrated an internal carbon price more for the scope 3 in our investment decision-making processes, to really give a price to carbon internally. So when we make a decision, we take into account the fact that carbon does have a price. That's an externality that we want to take into account in our decision-making process. both internally and internally. So internally for our own decision, but also we have included carbon price in the tenders, for example, that we have with our suppliers, where carbon cost is priced and is regarded just like safety, quality, and price. So that's an integrated part where we want to measure our scope 3 and then ultimately reduce also and incentivize the other players in the value chain to reduce their emission as well. So it's just 3 examples about what we do, our own emission. And then the last question, Stephanie, was how do you deal with this uncertainty between short-term and long-term? And that's a real one. I mean, especially for the investment cycles that we have in our business, which are quite long. When we build a line or a pylon, we think about 60, 50, 40, 60 years, depending on the design. So even today, we project ourselves until 2080, for example. So we need to have this visibility. And I would say what we do is we look at 4 main variables in our thought process. The first one is really, I would say, the societal changes that Julien presented. What are the market trends in terms of societal behavior, industrial processes, mobility, just to mention a few. The second aspect that we take into account is really the technology aspect. For example, to extract flexibility in the residential sector, we need to rely on new technologies because it does not exist today. So we do have also like a technology roadmap radar when we scrutinize what's going to be available in the coming years and decades. So technology. The third pillar is really also the regulatory context, both in Belgium, but also internationally. And the Green Deal, of course, is one of the masterpieces in this one that we take into account for energy efficiency, directive, carbon tax. All of these elements are considered in our scenarios. And then finally, the fourth dimension is also the geopolitics. And we have seen with the war in Ukraine how it's important and how we can basically really modify like the paradigm from one day to another. So we do have a lot of sensitivity scenarios on all of these elements as well. Not only for the geopolitics as such, but to see, for example, how a new geopolitics instability could disrupt the supply chain, for example, and what's the impact on that on our CapEx plan, for example. So just to mention a few, and then we have tools and scenarios when we project that. But balancing the short-term priorities with the long-term anticipation for Belgian society at Elia Transmission Belgium is one of our key, I would say, daily job. Just voilà, I just respect the 10 minutes, I believe, but happy to take any question as well.
Thank you so much. It's great to see this real life example, and thanks for thinking about that question as well. I mean, nobody has a crystal ball, but it's sometimes challenging to stay focused on the long term where we need to go actually with all the uncertainties coming in. So it's nice to hear that at least at Elia, you've got a lot of, not a crystal ball, but a lot of tools and processes in place to try and get there. So we have a few questions coming in, and for the last 10 minutes, I had one question that I wanted to ask you around, both of you, what do you think will be the biggest challenge for Belgium to get to 2050? And actually, I think it ties in nicely with a few of the questions that come in the chat, where Alain is asking about the political will to get there, and he's commenting that he thinks it's probably not the case. So maybe that's tied to one of the challenges that we will be facing. And Pascal brought up again, building a little bit on Anne's previous question, again on this societal will and how some of these changes might impact our well-being overall as a society, or our wealth, or how will the changes that we are expected to make, maybe that you've shown in your model, Julien, how is that expected to impact a bit quality of life in Belgium? Will it or will it not? And what is sort of the societal will behind it, in your opinion, that's needed to get there? not easy questions either, but I tie it to somehow the biggest challenge, because I think that's probably going to be it. But feel free to correct me if you think other challenges are in store for us.
Sure. I mean, my view and what we see in the studies we do is that there are really a lot of technological options, and the levers are there to be used. I think, as was mentioned, it's really about shifting gear and having the political and the societal will. To me, they're very connected. If there is a clear sign from the population, from society, that there's a will to move, then politicians tend to react, and they tend to be much more, short-term oriented. And so if they see that in the elections they'll be supported by societal will, I think that's going to help tremendously. So that's where I see indeed the challenge. And I think to do that, there's really a need for education and for understanding the impact. This is why I started the presentation not only on the solutions, but also really on the why and what's happening, because the world that we would go into in 2050 is really if there is 3 or 2 or more degrees, it's just not a world that we'd be able to live in. That'd be such a tremendous change. And again, I go back to the fact that it's very different from this average number to the extremes that we talk about. There are some great podcasts or talks about how that world is going to change. I was just listening to one this morning from Arnaud Rustan here in Belgium. If some of you know about Déclic le Tournant, he really describes the difference in a world between 1.5 and 2 degrees and what that means in 2050. And every percent counts. It's really the changes become massive, and the tipping points also become massive once you go beyond. So once I think the population, society, all of us realize the implications, and there's a lot more will, and then we can influence politicians a lot more as well.
Thanks. Pierre-Henri, did you want to add anything on that side? Or maybe on the challenges that you see?
Yeah, I would say my thought on this point was that whether we want it or not, I think also nature is giving some signs that we need to move. Again, whether we believe in science or not, signs are there. Also, financial impact are there on companies. Physical, linked to physical events, whether they are flooding, drought, whatever. But industrial will be hit also by consequences of climate change. And so I believe that this will, like climate adaptation and climate mitigation, will be taken into account as well to avoid either building stranded assets that may become stranded because of physical reason or regulatory reason. But the push will also come from society itself, I believe, from the business. Hopefully that will perceive the needs to be there. And this is what, in terms of governance, where the board has a key role, is what's the purpose of my organization? How can I make sure that the company I represent will still be there in 2050, 2060, knowing that we want to go to a net zero world? And so the key question for board members is, what does my company look like in a net zero world? And what should I do today? What decision should I take today to make sure that I'm still there in 30, 40 years from here? So I think political will be strongly important, and I think we all benefit from the Green Deal in terms of acceleration of the energy transition, but physical consequences on residential sectors and also industrial will also push society to look together in the same direction.
Great, thanks. And there's a few comments again on the societal will side and some skepticism that we will get there. But I think I hear from you both that we don't have a choice, so we should focus on getting there. Maybe to jump on what you said, Pierre-Henri, because there's a question for you around if ILIA has taken into consideration in some of your scenario analysis as well, some of the physical risks, and if that's also in Belgium in particular, something that you're looking at, flooding, in the climate, more on the adaptation side, if once these.
No, that's a very good question. Actually, and in the slide I show with the 5 dimension on E, S, and G we have developed at group level. Within the first dimension, climate action, we have 5 main objectives. 4 are related to climate mitigation, and then the 5th one is related to climate adaptation, which means how resilient is area infrastructure to significant events. The need was, of course, reinforced after the flooding in July 2021, when you remember, especially in the region of Liège, Hesse, where some of our substations have been flooded. And so since that day, so almost 2 years ago, we have launched a specific stream internally to assess the resilience of the current, but also the new infrastructure that Elia will build against heat wave, storms, cold wave in the winter as well, and flooding. So we have these 4 physical phenomena that we take into account now in our analysis, and that we are going to integrate in our standards as well when we build new equipment. We are also partnering with a university in Germany to go to a smaller granularity and to really have kind of a correlation between all of these 4 main events to like a few square kilometers to really analyze the impact of this event in terms of probability on where our lines, corridors, and substation are. So it's indeed really part of the ESG program as well at group level.
Thanks for sharing that. We have a few minutes left, and I want to get to the questions in the chat as well. And maybe for you, Julien, there's a few more questions based on some of the assumptions in the model that maybe you want to comment on quickly. And I think we can also share the model itself, and maybe so that there's some background information on the site as well for people who want to dig in a bit deeper. But the one interesting question, which we hear about this a lot, the fact that when energy efficiency, when technology becomes more efficient, that actually it leads to increasing use. So then it actually increases the resource demand. So there's a question from Catherine if those type of assumptions have been taken into account in the model. And also an interesting question from Laurent, which maybe one of you wants to comment on, around the sort of trade-offs with offshore wind and the fact that there's a lot of material going into building those turbines and the production and transports. What is the balance actually positive? So some of the externalities of wind production, which maybe you want to comment on.
Thanks, Stephanie. Maybe I'll start with that one because it's a relatively quick answer. And the answer is very positive. Yes, there's a very clear reduction with offshore wind, even if you take into account the build out in terms of greenhouse gas emissions. The range, if you look at the life cycle, is between, let's say, 5 and 30 grams per kilowatt hour or so. And maybe Pierre-Henri will have more specific numbers for Belgium. Gas would be around 300, 350. Coal would be around 700, maybe 1,000. So you're massively reducing the amount of greenhouse gases. Really, the other aspects, however, are important as well. You're shifting from a source that's based on fossil fuels to a source that's much more based on materials and on minerals. And you've probably heard of the risk and the difficulties around the amount of minerals that need to be mined. So there are also environmental issues related to other types of energy sources. So that's really not to diminish the impact of some of these alternatives, but that's also why I've tried to really capture this shift also that's required on the consumption in the societal side, to reflect the need to reduce our consumption overall. If we are in a world where we try to continue increasing total energy consumption, it's just not going to work, I think. But so in terms of carbon, for sure, it's very, very positive.
Yeah,
And
thanks.
so,
And I think you sort of answered the second question as well, that we also need to reduce our consumption and not just
building on
because
this
things
one,
are
maybe just in 10 seconds, Stephanie.
Yeah, please.
This question, I think what's important to look at it, and this is more on the midterm, long term, but what we do also is for all of this new equipment, especially wind offshore, is this question of circular economy and how can we make sure that we can reuse this material? Is the answer clear today? Not yet, but this is clearly a stream that we have launched also at ELIA to anticipate material scarcity in the coming decades and make sure that we can be as resilient as possible.
Thank you very much. And I see we're out of time, and it's been a very interesting discussion, and thank you both again for sharing all these insights. For those that were asking, we will share the slides and also the recording, so you can come back and read, and also we'll make sure to share the model itself, which you can go in and play around with. There's lots of interesting scenarios that come out. So yes, thank you very much, Julien and Pierre-Henri, both of you, for being with us today. I feel like this is just the start of the discussion.
To answer all of the questions, but don't hesitate to reach out if there's other burning ones, and
absolutely. Maybe I can share them with you, and you can type a quick answer if there's things that were
same on my
unanswered.
side. So to minimize frustration. So thank you for having me. Thank you, Julien. Chapter 0, Stephanie. Much appreciated.
Thank you both. Have a nice day. Bye. Everyone. Thanks for being there.